This video is going to walk you through calculating how to make a buffer of a desired volume and pH if you are being given the acid and its conjugate base. We have acetic acid, which has a pKa of 4.74, and we want to make a buffer that has a pH of 5. We're going to use the Henderson-Hasselbalch equation to solve this problem because we know the desired pH and we know the pKa of the acid that we're working with. So plugging that into the equation and doing a little bit of algebra, we can say that 0.26 is equal to the log of our base over our acid. We want to take the anti-log of both sides of this equation to get rid of this logarithm. So 10 to the 0.26 is equal to the base over the acid. And then we're going to work the math out on this 10 to the 0.26. It is 1.82. And that is the ratio of base to acid that we need in order to get our buffer to have a pH of 5. We can use any concentrations for the base and the acid as long as this equation works out to be 0.182. In order to keep things simple, I'm going to choose to have a base of 0.182 molar and an acid of 1 molar. And that works out in this equation, but you can choose a lot of different combinations of concentrations here as long as they work out to be 0.182 in this equation. So what we're going to do next is figure out how many moles of base do we need to put into 50 milliliters in order to get this concentration. And we'll do the same thing for the acid. For our base, which is acetate, we want it to be 0.182 molar, 0.182 moles per liter. We want to have a final volume of 0.05 liters, 50 milliliters. So doing the math on that, it tells us that we need to have 0.91 moles of acetate in our 50 mils of buffer. Now this is where we have to stop with this problem for the base, because we do not know our acetate if it's coming to us as solid, if it's coming to us as a solution. Is it sodium acetate? Is it potassium acetate? We don't know enough about the acetate in order to figure out exactly how we're going to get 0.91 moles of acetate. But this is as far as we can get. When we actually get into the lab and we see what kind of acetate we have, then we can finalize these calculations, figure out exactly how we're going to get 0.91 moles. We're going to do the same thing with our acid. We know that we want to have 1 molar acid, and we know that we want to have a final volume of 50 milliliters. So that tells us that we need 0.05 moles of acid in 50 mils. And again, we don't know anything about the acid that we're starting with. It's definitely going to be a solution, but we don't know what its concentration is, so we're not really sure how we're going to get 0.05 moles. But again, once we get into the lab and we see the molarity of our acetic acid, we'll be able to finish these calculations.